Hey everyone, welcome to this conversation on the Bitcoin halving. I tried to record this on a webinar about a week ago, but had some issues with my streaming service and my internet connection, so it didn't come out great. So I wanted to re-record this so that anyone who is interested in learning about it would be able to. Start off with a disclaimer. I won't be giving any investment advice, won't tell you to buy, won't tell you to sell, things like that. Feel free to pause the video and read the disclaimer. A little bit about me. My name is Dalton Cole. I am one of the two partners. I am the Chief Technology Officer at Digital Opportunities Group. So I oversee the order and execution management systems we build out internally, the portfolio management systems we build out internally, all of our monitoring and infrastructure that we operate. My background is in fintech. So I've worked on core banking projects, I've worked on payment systems, I've worked on smart contract development and data science projects. I'm also a Bitcoin blockchain node operator. So I have a node running in my pantry. Looks like this. So what my node does is the same as all the other nodes, except for miners. I do not mine, so I'm not making any money off of this. Costs me a little bit of money in electricity, and then obviously the hardware. But it stores the Bitcoin blockchain, so that's all transactions that have ever happened. And it maintains a mempool of pending transactions. So what it means is before a transaction is bundled up into a block by a miner, and added to the blockchain, we just have this pool of pending transactions. So these are people with their transactions. They've got their transaction fee attached to it and say, hey, pick me, add me to the next block. And then the miners decide whether or not they want to add that transaction to a block based on, typically as an auction mechanism, depending on how much that person is paid, because the miner gets that transaction fee. Bitcoin transaction lifecycle, we'll just touch this lightly. I won't be going into too much detail. But essentially you would have a Bitcoin wallet, you sign that with your signature. That wallet is connected to a node, so it will emit the transaction through the node to the network. The nodes verify the transaction, store it in the mempool. As I mentioned, that's kind of like that temporary area when it's waiting for the miners to pick it. During the time the miners are competing to solve a puzzle, you might have heard that these computers are just kind of guessing numbers or working on a puzzle to determine who gets the reward and who gets to earn the Bitcoin. It's kind of how it works. Essentially, the Bitcoin code itself is configured to adjust the difficulty of that puzzle depending on how many computers are participating in the game. And essentially, whoever guesses first wins and gets the block reward. Also gets to compile all the transactions that they want into a block, collect those transaction fees, emit that block to the network, and then all the nodes will verify and update their blockchains with that block. What is a block reward? So the block reward is what the miners earn. As I mentioned, they get to collect all the transaction fees from the transactions they bundle into a block, but they are also awarded a block subsidy. So you can think of that as something that the Bitcoin network pays to miners in order to compensate them for participating in it, because the transaction fees alone are not enough for it to be profitable. So you can think of like any other subsidy. If you're in the U.S., you might remember the PPP loans or payroll protection plan loans, or payroll protection program maybe. But essentially, those were forgivable loans by the government to subsidize people who ran small businesses or ran any type of business in order to thank them for participating in the economy during that time of COVID. Same thing for Bitcoin. The block subsidy is a way to compensate miners for participating in the early times of Bitcoin. So what is a block subsidy? The protocol creates new Bitcoin in each block. That's the only way Bitcoin are created, is as subsidies. They're used to incentivize the miners. So in a block, you have a list of transactions that are included in the block, and then also this subsidy transaction, which is just sent to the miner of new Bitcoin. So there's no from address, it's just to the miner. The subsidy gets halved every 210,000 blocks, and it's the only way Bitcoin are created. It started out as 50 Bitcoin, and now it is less than that. And tomorrow will be even less than that, because today is April 18th. Tomorrow, April 19th, is the estimated time for the fourth halving of Bitcoin. So we'll go from 50 Bitcoin per block, which was the first one, 25 for the second one, 12 and a half, currently 6 and a quarter. Sometime tomorrow it will be chopped in half again to 3.125 Bitcoin per block. Show you a little bit of a demo on the box. So this is connected to my home node. We can see that the fees, we can see all these transactions in the most recent block. We can see who mined it. It's the F2 pool miner. We can go through all these transactions if we wanted to. But all we really care about today is the total fees. So that's actual transaction fees. So there's $60,000 worth of transaction fees in here. They're color coded. So the guy that's green got a good deal. The guy that's red, not as good of a deal. But the actual block reward is this combo number of subsidies plus fees. So it's $450,000. So that means that about $390,000 of that was the block subsidy. So a substantial portion of miner revenue is these block subsidies. And the transaction fees are much less. This is a chart of the historical percentage of block income that transaction fees represent. So you can see we're spiking right now to about 20%, which aligns pretty well with what we're seeing in these numbers now. And for the last few blocks, it looks like that as well. Bitcoin was a little higher last week when I recorded this. So you were seeing transaction fees of $100,000 and total block of about $550,000 for the block reward. But now that Bitcoin has gone down a little bit, obviously the dollar value of those blocks goes down. But you can see we're up to about 20% now. It's pretty volatile. There's a lot of spikes and drops. The average is probably pretty low. So these halvings are substantial for Bitcoin miners. If we assume the average here is, say, 8%, 5%. If we say 5%, then 95% of the revenue is coming from those actual block subsidies. So having that number cut in half tomorrow for the number of Bitcoin you receive is substantial. How is a block subsidy calculated? So this is the actual method that is inside the Bitcoin core code, which we'll show shortly. It's called get block subsidy. It takes in the height of the Bitcoin, so that's the number of blocks, the height of the blockchain, which is the number of blocks. So it's not a chain that gets longer; it's actually a chain that gets taller as you add new blocks on top. So that's why we think of it as height. And then there is a consensus param object within the code as well that just has a bunch of parameters that are configured. One of them, and the only one we care about today, is the subsidy halving interval, which is that 210,000 number that we talked about earlier. There's also coin, which is the number of Satoshis in each Bitcoin. That is a number that's configured inside the code as 100 million. So there are 100 million atomic units inside each Bitcoin. You can't go less than one Satoshi. You can't chop those in half or anything like that. So there's 5 billion Satoshis in the first subsidy. So it's 50 times 100 million. And that gets cut in half every 210,000 blocks. So the first subsidy, we would have had no halvings. So that would have been 5 billion. The next halving, we would have gone to 2.5 billion Satoshis all the way down to where we are now. This is called a bit shift operator or a bitwise right shift. And what this is a way to cut a number in half a certain number of times. Because with a binary number, every time you shift it to the right one, you're actually cutting that number in half. We'll go into a little bit of detail how that works in a second, but that's how that works. And then it returns a number. So if there are more than 64 halvings, then it just returns 0. There's 0 subsidy for that block. If it's less than 64, then what it's going to do is run this code, which is actually 0 much sooner than the 64th block or halving, and we'll get into that in a moment as well. So as I mentioned, there's 3 variables associated with this function. We've got the height of the blockchain, which is the number of blocks. Coin, which is the number of Satoshis or the most atomic unit of Bitcoin, set to 100 million. The halving interval, which is set to 210,000. So now we're going to walk through some of the code. The Bitcoin core code is public. You can look it up on GitHub. The organization is Bitcoin. The repository is Bitcoin. You can download it and run it locally, which is what I've got, and we'll show you in just a moment. But it's good to check out. You can see all of the contributors. We'll be coming back to this shortly as well to talk about how Bitcoin could be updated in the future. But for right now, we're going to look at some code. So this is the get block subsidy method that I talked about earlier with the block height and the consensus param arguments. We drill into the consensus params and just grab the subsidy halving interval. We divide the height by the subsidy halving interval. That's going to be an integer, so we're going to round down that number to the nearest whole number. So if height is 211,000, we're going to divide that by 210,000, which is going to be 1 point something, and we're going to round that down to 1. And then we're going to say 1 is not greater than or equal to 64, so we're going to proceed to the next line of code. And we're going to take 50 times 100 million, we're going to get 5 billion, and then we're going to shift in subsidy the number of halvings. And since there's been one halving, we're going to shift it once, which when we get to our little spreadsheet shortly, we'll show you that shifting it once is going to cut that 5 billion or 50 Bitcoin or 5 billion Satoshis. It's going to cut it in half to 25 Bitcoin or 2.5 billion Satoshis. It's going to return that number to the rest of the system. So the chain params or consensus params, we can see 210,000. So that's our in subsidy halving interval, which is the same thing that we're referring to here in subsidy halving interval. We've got our amount from the consensus directory, and we've got 100 million. So even this comment tells you it's the amount of Satoshis in one Bitcoin. As I mentioned, a Satoshi is the most atomic unit of Bitcoin. It's like the penny of the US dollar. There's also some code here that's interesting called max money. And so there's random sanity checks throughout the Bitcoin core code that pretty much says if this transaction is more than max money, or if the total Bitcoin supply is more than max money, there's something wrong. It returns true or false. So it's a Boolean, which means it's true or false. And we just want to make sure that the value of whatever is happening is less than 21 million times Satoshis. So whatever 21 million times 100 million is, we want to make sure that nothing in the Bitcoin network is happening that is greater than that number, because that means that something is obviously wrong. So it's just kind of like a sanity check. There's no place in the code where it says specifically that Bitcoin cannot be over 21 million, or 21 million, other than this line here as a sanity check. The reason we get to that 21 million number is just based off of how the halvings work, when the halvings stop, or when the block subsidies stop, and what the number of Bitcoin will be at that point. Because once the block subsidies stop, because that's the only way that Bitcoin can be created, we will have no more additional Bitcoin generated. So I've created a little bit of code here. This is actually Python code to demo how the block subsidies work. So this is actually written in Python instead of the original C++. Just a little easier for me to demo that way. Move my little picture over here so you can still see me, so you don't forget how handsome I am. Let's see. Just import everything from demo halving. Sorry, get my languages mixed up. Okay, so if we take a block of, let's say, 211,000, and we want to get block subsidy of that block height, we would expect 2.5 billion, which is correct, because as I mentioned, we started out at 5 billion, and then every halving we cut in half. So if we were to change that block height to 209,000, which would be before the first halving, we'll see that we get 5 billion, which is also correct. Scoot this up just a little bit for you. And then if our block height is really high, I accidentally put a 0 there, we should get a 0 subsidy, because these do run out. So you can see that that does return 0. Okay, all really interesting stuff. Okay, now we've got the subsidies worksheet that I put together. So this will also be linked. We've got little notes at each column to explain why I thought that was interesting. I whipped this up myself. We've got the number of the block subsidy in Satoshis. That's actually a formula that handles these binary sequences that are generated. The reason I have the binary number in here is because of that right shift operator that we talked about that shifts everything to the right one, every halving. So this binary number is a 64-bit representation of 5 billion Satoshis. And you'll see as we scoot that over, we shift it over right to the 1, we drop off a 0. So it scoots everything to the right, drops off a 0, and that cuts something in half when it comes to binary. So that's how we get to 2.5 billion. And then if you prefer to think in terms of Bitcoin, we go from 50 Bitcoin to 25 Bitcoin to 12.5 Bitcoin, 6.25. And then the actual start and end block for those epochs, and then the approximate year that they will happen. So we're in 2024, April. We're having the fourth halving, so we'll be having from 625 million Satoshis down to 312,500,000 Satoshis for every block after this. And then this is the amount of Bitcoin generated at the start of each halving. So right before this halving, we will have 19,687,406 Bitcoin. And you see that happens at block 840,000. So 840,000, you can divide by 210,000 to get an even 4. And current block that was just mined was 839,823. So we're very close. We're 177 blocks away from the next halving. Another thing that is interesting, as I mentioned, the Bitcoin gets block subsidy code returned 0 after the 64th halving. But that is just because with a 64-bit binary representation, you cannot shift it to the right more than 64 times, or else you'll error out. There's no more bits to be shifted. So you can see once we're at the 63rd halving and we try to shift it, so as the 64th would do, there would be nothing to shift. So we just short circuit that code and return 0. But we actually have 0 Satoshis minted as of 2140 on the 33rd halving. So we will have 0 Satoshis minted, and then the code will start to short circuit itself for like 120 years. Before that, we'll just have 1 Satoshi minted. So the smallest number of Bitcoin will be generated with every block for a full 4 years. So we'll have to see what a Satoshi is worth at that time. 2140 or 2136. I probably won't be around. Hopefully it's not worth too much, or else that will make transaction fees very expensive. So we'll have to see. One thing that's being discussed right now, and has been since the beginning of Bitcoin, is once block subsidies go away, will transaction fees be enough to pay the miners to secure the network? How high will transaction fees need to be? Will it be so high that the network becomes unusable? Now you have a lot of layer 2 Bitcoin networks that are spinning up. You've got Lightning and a few other things that aim to solve that. We'll see if it works, but that's how the math works for halvings and the bit shift operators for sliding these binary sequences to the right. Let's see what we got next. What is Bitcoin Core? So I just walked you through a little bit of Bitcoin Core code locally, and then also showed the repository. You can also go to their website where they talk a little bit about Bitcoin Core, but it is the implementation of the original Satoshi Nakamoto white paper. Essentially, Satoshi Nakamoto is the anonymous writer of the Bitcoin white paper, wrote the code that reflected what was in the white paper, deployed it, and this is what's in Bitcoin now. Who are the contributors? When I wrote this, there were 946,000 contributors. If we look at Bitcoin Core now, 946,946, and there's 949 now, so 3 guys hopped in the last week to make some tweaks to the Bitcoin code. So these tweaks are typically small. They're going to be performance improvements. This code not only controls Bitcoin Core, but also has a wallet attached to it, so there might be some UI updates to the wallet. Just a couple of different things that could be, but there's 949 people that have contributed to the Bitcoin code. The maintainers, so these are the people that can actually merge in those changes. So you've got a community of contributors that are making changes, recommending them, proposing them. But there's only about a handful of developers. We've got 5. It might be less than that now. So only a few people in the world can contribute or can merge those proposals, those proposed changes into Bitcoin Core code. Once it's in Bitcoin Core code, then the actual node operators can decide whether they want to upgrade to that latest version. So there's a little bit of a governance there between contributors recommending code, maintainers merging that code in, node operators determining whether they want to accept those changes, And then you also have the wallet providers determining what nodes they want to be connected to. So if your node accepts a change that the wallet provider doesn't like, they can swap over to a new node. So if you're with Coinbase, you've got a Coinbase wallet, or say you're in an ETF that is backed by Coinbase, Coinbase is deciding which nodes they're attached to. They probably run their own nodes. And so they can essentially choose what changes in Bitcoin that they want to accept. For major changes, if not everybody accepts them, then it creates a fork in the blockchain. Some people are running a different version of Bitcoin at that point, essentially. And then the true version of Bitcoin is essentially whatever the wallet providers determine is a true version of Bitcoin, or whoever the majority of users decide. So that's called a fork. So node operators, as I mentioned, they're responsible for running Bitcoin Core. They're kind of like librarians of the network. These are what the wallets connect to determine what's in the blockchain. A fork is created if they do not choose a major update. So major updates in the past have been around scalability. So that's going to be the size of the blocks in the blockchain. The larger the block, the more transactions you can put in, because there's only one block per 10 minutes. The larger those are, the more transactions you get in every 10 minutes. That has happened once on Bitcoin. Current Bitcoin, known as Bitcoin, it went from, I think, 1 megabyte to 4. Average blocks about 2, or a little less than 2. But there's a couple different ways people can change Bitcoin. So previous forks: Bitcoin XT, Bitcoin Classic, Bitcoin Unlimited, Bitcoin Cash, Bitcoin Gold, Bitcoin Satoshi's Vision. Most of these are just performance increases. So this might be changing the way the consensus algorithm works. It might be changing the number of transactions per block by changing the block size. All sorts of ways where you can tweak Bitcoin. But as far as current Bitcoin, that everybody knows is Bitcoin, that's worth $60,000 today. There's a couple ways it could be changed. Specifically around this get block subsidy is what's interesting to me, because one of the things that people love about Bitcoin is there's only going to be 21 million Bitcoin. And that's true of the current iteration of Bitcoin. But there could always be a fork. Wallet providers, Coinbase, all these other large companies could decide that they're actually better off if Bitcoin continues to produce Bitcoin instead of stopping at 21 million. They've never come out and said that, but it is, if they're heavily invested in mining companies, they may want to keep those subsidies running. So it's an interesting topic to me specifically. And one of the most interesting things about Bitcoin is what's going to happen with this. But if we wanted to change the block subsidies, it would be fairly easy to do. So as we saw in line 1755 of the block subsidy function, where we return 0, if this was to return 1, then you would generate 1 Satoshi every block forever. You probably want to do it before the 64th block. You probably do it at the 33rd block. Otherwise, it would mint 1 Satoshi, and then from 33rd halving, not block. From the 33rd halving to the 64th halving, you would have none, and then after the 64th halving, you would have 1. I wrote some code to explain how you could do this. We'll get to that in just a moment. But you would also need to change that max money argument or variable that we talked about. They currently is set to 21 million. You could change that or actually remove the sanity checks altogether. You would expect the Bitcoin code to be a little bit more hardened by then, so that we don't need as much of that. But one way we could change this so that we could essentially have infinite Bitcoin over time, so you would have a steady rate of inflation, but it would still reward the miners for participating, and hopefully by not too much. We've got this code that I wrote. So what this is like a new, I just called it get block subsidy new. So what I did is, if the halvings are greater than or equal to 6, return 100 million. So just return 1 Bitcoin for every block that's generated. So the miner is always rewarded with 1 Bitcoin. And the reason I chose greater than or equal to the 6th halving is because if we look at our block subsidies chart, once we get to the 6th halving, it's the first time that we're actually awarded less than 1 Bitcoin. So when we go from the 5 to the 6 in the new code, it will always reward 1 Bitcoin instead of 0.78 and then continue to being halved. It will just forever create a new Bitcoin, which means the total supply would be uncapped, but you would be able to project it out infinitely, because you know that there's always 1 Bitcoin per block, and 1 block is every 10 minutes. I won't be formally proposing this, but this is just an example of how this would work. So if we take our block height and call it a new function, you can see that this crazy high block number before, with the original get block subsidy function, we got 0 subsidy. Now we'll get our 1 Bitcoin for forever, which is pretty interesting. It would be an interesting way to solve the problem, and probably not that big of an economic impact by adding 1 new Bitcoin per block. Depending on how much Bitcoin is worth, it could be a pretty huge reward for miners at that point. If you have any more questions, you can reach out to me. My name is Dalton Cole, as I mentioned. My email is dalton@digop.group.